Okay, guys, here we go. Let's take a look at graphing this cosecant function, okay, and how we're going to proceed with that, okay? Now, the first thing that you have to recognize when you're graphing the cosecant is really what you're doing is you've got to first graph the sine. So we know that the cosecant is 1 over the sine. So this expression is 2, -2, over the sine of 2x minus pi. Okay. Now the period, the phase shift for this cosecant function are going to mimic that of the sine. Okay. So in terms of the period's always been the normal period, which for sine is 2 pi over b, 2 pi over b. So that's 2 pi over 2, which makes this a period of pi. Okay. The phase shift again with secant, cosecant, the same as it's been with sine and cosine, c over b, c over b. So that makes it pi over 2. So we got a pi over 2. The direction is to the right, okay? Opposite that of the sine. Now the domain, the range, that's going to be dependent upon the graph, okay? So, so really, when we're graphing the cosecant, we're actually going to graph this sine function. Here's a sine function quite simply, right? Quite simple sine function. Crosses the axes beginning, middle, and end, right? However, we've shifted it pi over 2 to the right, okay? And we're ending pi down the line. So the wavelength is going to be pi down the line, okay, which is going to end us up here at 3 pi over 2, okay? So 3 pi over 2 is where we end. Midway is pi right here, okay? So that's our graph mapped out. Here's pi over 2. Here's going to be our axes back here. Um, and it's going to get a little congested, as you can see. So here's going to be our axes back here. Um, and now we're going to come in and we're going to take every, I'm going to change colors here so we can graph, okay? Now, we know that the cosecant is going to have its asymptotes wherever the sine has its intercept. So let's come in, let's sneak in our asymptotes right here at pi over 2, pi, okay, 3 pi over 2. And so now, since they're going to be asymptotes, they're going to be interruptions in the domain. So we can see it's going to be a pi over 2, then pi over 2 down the line at pi. So another 3 pi over 2. So it's actually the domain is that x can equal anything but pi over 2k. Anything but pi over 2k. All right. Now, all we got to do now is come and sketch every value of this multiplied by -2. So here's a 1, going to multiply by -2. That's going to push us down here, and it's going to make our graph be a little down here. Okay. And multiplying this one, -1, by -2 is going to push this up here. So we can see that our range is going to run from -infinity to -2, and then from 2 on out to positive infinity. Now, I've also done this, drew this up on Desmos, okay? A little cleaner than what I have here. So let's go and take a look at the Desmos variation on that graph. So here it is, okay? So here is, first off, my sine graph, okay? Um, Here my sine graph is, starting at pi over 2, ending at 3 pi over 2. There we go. Okay. There's the halfway. There's our quarter wave points. Okay. All right. There and there. All right. So they're all there like we would expect. Okay. Now, what am I doing? Again, my cosecant graph comes in and is graphed now. And as I said, wherever the intercepts of the sine occur is where the asymptotes occur the for the cosecant. Okay, wherever the intercepts for the sine are is where the asymptotes for the cosecant. So there they occur, right there, pi over 2, all values of pi over 2, pi over 2, 0, negative pi over 2, pi over 2k are where the asymptotes are. And again, we took the value here of 1 and we multiply it by the -2, which gives us right there. That's our value right there. You can see that. 3 pi over 4, -2. You can see that this value is right here up at 5 pi and -1. Okay, so that's very much the graph that we saw over here that I drew up for you. Okay, and maybe we'll take a look at the next one in another video. Okay, so that should do it for this one.